Hello, everybody. Yeah, like you said, my name is Franz. This is Adriaan. Yeah, we made a 2D pixel game in Godot called Rift Riff. You can see it on the screen here. It's been playing ever since you came in, so absorb it. But yeah, we want to talk about our experiences specifically making this game using Godot. So first of all, what is Rift Riff? Maybe you can tell already. Maybe you've even played it, which would be fantastic. But it's a tower defense game with strategic tower placement, a lot of different types of towers that you can have in your loadout when you load the level. There's different enemy behavior that can target different towers. And we're actually quite proud of having quite forgiving mechanics. Such as if you want to trade your tower in the middle of a level, in between waves, you can sell them for a full cost refund. And if you lose the wave, you don't have to restart the whole level.
Yeah, so a bunch of days ago, I think it says there, May 9th, yes. May 9th we released Rift Riff, and it went really well. In terms of marketing beats, of course, everything that we wished and hoped for happened. But technically speaking, and also in terms of production, it was something we are very, very proud of, and we'll continue to work on a little bit longer with pride. And we're getting very, very nice results also from players who love the game. 98% positive reviews right now, so players love it. They're excited, and obviously there's always bugs. Some are our fault, like this one, where we have clearly done some things with complete disregard of potato machines. And some are bugs that might be in Godot, but that's something that we'll talk about a little bit later in our talk.
Yeah.
Simple, yes. Yeah, simple.
So yeah, we made this game with a small team of 5 people, so it's not just the 2 of us up here. And we didn't want to give you a full overview of how to Godot. There's lots of YouTube and all kinds of courses online for you to learn how it works. Actually, Adriaan even made one of those of how to go from Unity to Godot, and I think it's on YouTube. So we're not going to really cover that, but we wanted to cover what was our workflow, and specifically we wanted to showcase the workflows of the different game dev roles that we covered. So the first one is developer, then we'll go into level designer, artist, and sound designer. So yeah, developer, that's us. I worked as a developer as well on it. We use Godot's built-in GDScript language along with the native script editor. GDScript is quite robust and has like autocomplete functions for its for all the variables that you have predefined, and it has a great integration with the inspector. The inspector is on the left side of the screen here, and basically it's as you create and export variables and custom variables, you can edit them directly in the scripter, so people that don't go into the code can tweak things that way. There is C#. You can use that for those that know C#, but you need to use an external program to compile it, like VS Code and JetWriter. But because of compile times, that was one of the reasons we decided to use GDScript instead. Then we also have some fancy tools, including in-game editing, where we can click on objects basically while the game is running, and then it will pop up in the scene tree, and then you can go ahead and edit in the inspector directly while the game is running. You can also do what's called hot loading, where you can actually edit the GDScript itself and save it while the game is running. Here I'm just playing around with the speed of the character and then making them super fast, so you can use that for tweaking, your level design or game design, or you can even add in full extra lines of code as long as you don't introduce something that breaks the game, of course. Yep. There's also excellent API documentation. As was mentioned in the introduction, I don't come from games. I taught myself completely how to code, and 80% of what I used was the API documentation. It's really good. So if you want to jump into it, just go there as a starting point. And so there's resource scripts, which are similar to Unity scriptable objects, and we use these to create custom data containers, which are also known as resources. This we use a lot in our game, and I think a lot of Godot games will rely heavily on these custom resources. They're data containers that are used for everything from textures, scripts, animations, audio streams, and so on. So one of the examples of where we used one was we created basically a template for the tower design for our tower resource. And for that, it would basically define which object would be instanced when you create that tower, as well as some UI elements, core variables like range and cost of the tower. Another example is enemy resources, where you define things like enemy behavior and type. So all of these tools the developer used, we used in order to help make the game, but we also made some other tools to help some of the other disciplines as well, such as the level designer, which we'll jump into now.
Segue to me.
Yes.
So together with Professional Panda over here, we were the two level designers for Rift Riff, and we used a lot of the built-in tools that we had for Godot to make the levels. Most of the levels started like this, where it was just a polygon editor, just drag a bunch of points around. Then we'd have a tool to generate the collisions of a level based on that particular polygon. And from that, we could very easily generate a navigation mesh and have enemy behavior instantly. So this is already a fully functioning level where enemies can spawn from the spawn point, and we could both playtest the level this way. So for, I think, the first half year of our project, all the levels basically looked like this. Didn't look very pretty, but we could at least play them and get a sense of how fun the waves, enemy waves were that we designed. So as Franz mentioned, we were using custom resources, and this was also the case for the enemy wave design. So the waves are actually a data container with a bunch of custom resources called waves, which then included custom resources for the spawns. So here you can see that data structure layout, right? There's the waves, an array of waves, and there is within each wave an array of spawns. And that's essentially how all the spawns were designed. So Professional Panda and I, we spent a lot of our time just in this interface, thinking about the little numbers that are in there, thinking about the experience for the player. One thing I wanted to mention here, which I think we'll talk about a little briefly afterwards as well, is that inside this inspector that you see here, there's a bunch of things that are not normal, like this extra label here just under the wave thing that says 24 juice generation +8 with generator companion. That's like a little custom inspector that we built on top of all the stuff that is in Godot. If you're used to Unity or you've already played around with Godot a little bit more, you know that editor customization is a thing, and that's certainly also something that we took into this project. So once we have the level design, we enable our art person, Sim Kaart, to work on the art for the game. So he generally pixel arts within software that's called Asprite, and then there's an open source plugin to take the Asprite file, drop it in Godot, and together with a bunch of animation tools that you see there at the bottom that is, again, built into Godot, he was able to make a bunch of levels, bring them in the game, place them in the levels, and yeah, you end up with a full level that looks like this.
Yeah, now on to sound and music design. So we had Matthias, who's a sound engineer, and basically, so he did not have to work in Godot and learn Godot as much as we did. We created these custom objects that we called sound containers. So he could focus on making the sounds and the music that he does best, and all he has to do is drag and drop them into these containers that are hooked into our, again, custom-made music and sound managers, which will adapt all the logic from those sounds, from that music, and do things like fading between tracks and adjusting the levels and so on. There's also an audio bus panel that is actually built into Godot that allows us to create custom buses and gives Matthias all kinds of effects to tweak and to layer to get the sounds really to where he wants them to be in the game.
What's really fun is that I think nobody else in the team really understands what's really going on here.
No, not
There's so many filters on there being used with compressors, hard limiters, all sorts of stuff. And it's really fantastic that Godot has these features.
A few other important features, these UI tools, so-called controls. You can see in the left inspector over there, those are all the controls that we use to create this settings menu, which is I'm displaying in the center here in the embedded game editor here. So it's a responsive design using anchors. It also has customizable and it's themable, and it supports multi-input. So we use this for all of our UI creations.
Yeah, pretty happy with that.
Then there's localization tools. Godot has some built-in tools that allow us to generate a localization template, which we exported to other software to actually translate the game. I don't know if you want to elaborate on that, but that's...
No, yeah, I mean, I'm very happy coming from Unity. I felt that this was always missing, and here it was just really nice to see it built in, and there immediately being a button you can press, and then, ta-da! There's a whole template for localization. So that was very smooth in my experience.
So there's a bunch of features we didn't use that people will probably have questions about. The most obvious one is 3D. We did not 3D, we 2D'd. We are a 2D game, so we obviously didn't use the 3D functionality of Godot. And I know some people have heard that, oh, Godot is great in 2D, but what about 3D? Well, ever since the 4.0 release a couple years ago, a lot of more 3D features have been introduced. There's going to be a lot more higher profile games using 3D in Godot that are coming out in the future. There's a couple screenshots up there. Actually, one is already released. Buckshot Roulette is made in Godot. Then there's PVKK in the bottom left, and in the bottom right is Road to Vostok. So they're definitely coming. Physics is another thing that we didn't use much. We had some basic collisions, but that's about it. There is, ever since Godot 4.4, which was released just a few months ago, they introduced the open source Jolt physics engine, which apparently is the same engine that was used in Horizon Forbidden West. So it has been battle tested, and I hear it's pretty good, but we don't have too much experience with it. And shaders. So we did actually use some shaders in the game, which we remembered later. But we used two to make a dynamic vignette that changes depending on whether or not the wave is activated or not, as well as there's trees and bushes that sort of sway in the wind. But otherwise, we didn't use shaders so much. But there is shader tools built in as well. They use the language very, very similar to the OpenGL shading language for embedded systems 3.0. So if you know that, you'll be familiar with it. It also carries over a lot of the same functions. And then finally, yeah, the C# language is something that we did not use because we went with GDScript, of course.
Yeah, so that should give you at least a bit of an overview of all the stuff that we've been using. Of course, there's a lot more details to talk about, but I wanted to jump to the following: multi-platform exports, plugins, and store integrations, because, of course, as game developers, you want to become sustainable doing what you love, and then this is a very real important part of that. So let's talk a little bit about that. Godot has export presets. It works a little bit different from Unity, where you first select the platform and then you sort of have to script your way through making it work for each specific platform. In Godot, it works slightly different, where you can essentially do that customization by adding a new preset. So here you can see a whole list of Windows, Mac, Linux, and iOS and Android builds. And every time you click on one, you can have different settings for the exports, like a different folder, maybe enable or disable entire features. And this was very, very convenient and customizable to work with. On top of that, what we did was wrote a little bash script that is honestly extremely easy to set up. It's essentially, there's much as this code that you see here is just echoing, so printing some text on the screen. The actual line, it's a single line somewhere at the bottom over here, is how you make an export without running Godot at all. And it was very straightforward to do. And yeah, we made a batch script that not only creates a bunch of builds, but also sends it to Apple for notarization, waits for the results, and then ends up also pushing the build to Steam. So one press of a button and we export to all platforms. And this was like 3 hours of work to get this working. So very proud of that.
Yeah, Godot also has like a community-driven ecosystem. From what I understand, it is not as large as Unity's, for example, at least not yet. But there are many GDScript plugins. So what those are, yeah, basically someone has created a tool directly in the Godot engine using GDScript, and they exported it to the plugin store, if you will, where other people can come and download it and plug it into their workflow. Yeah. There's also more powerful and performant ones that are built directly in C++, called GD extensions. So for those that don't know, actually, Godot Engine, the underlying programming of the Godot Engine is C++, and that's what's used to compile the Godot Engine. So if you can make these GD extensions, you can plug them in, build them in directly to a compiled version of the Godot Engine. And we use one, such as this example, the Godot Steam, which is quite well updated and very, very, very handy if you're going to release on Steam. It is probably the one to use because it's a module that's very easy to install and incorporate into your project, and it basically gives you access to Valve's Steamwork SDK features, such as achievements, stats, and cloud saves, and so on. So you can use all of that functionality directly within your GD scripts and the functions that you're creating. Oh, that's me, yeah. Sorry. And nearly all the plugins are open source, which is also the beauty of it, which means that not only is it very relevant for long-term support, but you can also take a look at the code to see if you understand something or not. If you so wish, you can even contribute to it. Or if something is not working for whatever reason, then you can figure out why.
Oh, yeah, that's me. And of course, I mentioned this before, Sprite, a software that's among pixel artists used very much. And there's just this community plugin, not even really affiliated with the person who made Sprite, just some guy who's chucking away on his keyboard, making this plugin. But then you can see it really being picked up by the community. So it ends up, it starts as being created by one guy, but then because it's open source, more and more people start reporting issues, working on PRs, contributing code, fixing bugs, etc. And then you end up with something like the Godot Sprite wizard. And of course, there's also plugins that we wrote ourselves, such as a custom translation parser, a version increment script plugin, and the wave data inspector. So I know also that the Godot Foundation, which I'll talk about in a second, is also setting up a asset store, so more like Unity's asset store where you actually have to buy assets, but that currently doesn't exist, and part of the reason why everything is open source now, because that's how people distribute their assets. But that's coming soon, I've heard. So for us personally, if we find enough time and success with Rift Riff, like it has done financially okay-ish, but a little bit on the low side, once it starts increasing, hopefully soon, then porting to a console is an option. The way that we would approach it is we would go to these people, W4, found a company founded by a bunch of Godot Engine veterans. What they do is they take the open source engine, they add to it a bunch of SDKs to include console support, and then they essentially give you, they sell you access to that version of the engine. So it is services built on top of the Godot engine. I believe that Shana will talk a little bit more about that later, also in this room. This solution, for even for indie developers, I find it extremely affordable. We're talking about $800 per year per console. That is very, very, very cheap. If you want to do all three consoles, you're looking at something like $3,000 per year for access to this. That is, again, so very cheap because, well, comparing it to something like Unity, we're talking about 2 Unity licenses. The price for 2 Unity licenses. If you have a small team, this thing is already going to be cheaper.
So yeah, regardless of engine, of course, bugs and crashes exist, and Rift Riff was no different. We had some examples that were a bit of head scratchers. This example, for example, we had some that would crash on launch, and then people realized that they could work around by using the OpenGL rendering device. So we found this, and we're like, okay, is this an engine bug, or is this one of our bugs? But the possibility that we could actually compile a version of the engine and game using additional debugging tools to help us figure out this problem is what was nice about it. And we can actually start investigating and going down those routes should we see it become a real problem. In this case, there was a workaround, and we haven't seen it pop up too many times, but there's always that possibility. And the reason for that is, of course, because it's open source. So we've mentioned open source quite a few times, so let's dive more into that.
Yeah, let's talk a little bit about open source, because I think for most people who have who are even just a little bit business savvy, you're asking yourself, okay, Godot is free. How can that work? Like how is it possible that people are working on this? So first, let's give you a bit of an overview of how people actually work on Godot. Most of it happens on GitHub. People who find issues with it report that in the issues tab. People who want to contribute code go to the pull requests tab and they push their code there. And then there's a separate repository that allows people to make proposals if they want to see a change in the engine. And then you will find people who actually contribute with C++ code onto the engine. You will find that they end up discussing these proposals in the comments of these proposals. So there's a lot of open, very transparent back and forth with the community and the people who are capable of contributing to the engine. But slightly away from the public is also something called Rocket Chat. That's where all the engine contributors chat among themselves, thinking about solutions, thinking about how to address problems, etc. And they also organize open meetings, by which I mean they organize weekly or bi-weekly meetings with specific teams, for instance, the GDScript team or the rendering team, to then discuss, what are the proposals that came in, what are the work that's currently being done, how do we prioritize this, how do we go about this, and it's all open. Any of us could join these meetings. But I think what's very important here to note is that if you want to see a change and you're working in a game on the Godot engine, you have to invest a little bit of time. If you see an issue, you want to report it. If you feel like your workflow is not supported, you want to create a proposal and really think about how will my workflow be more optimized, and these are the features that would do that. So Godot is in that sense very different from Unity. Godot is organized by the Godot Foundation, which has sponsors like myself, but also a bunch of other companies, and I think that's very much at the core of how Godot functions. Companies have needs, and they hire people to fill those needs, and then they push those contributions, they push it, what you call upstream, they push it to the live open source version. And I think that's a very inherent part of this, how this open source can work, if that is if companies pay for specific features and then push them to open source so everyone can benefit.
So yes, what's next for us and Rift Riff? Well, this was always started as kind of an experiment to see whether or not we could make a game in Godot and release it on Steam. So, we did that. We think it was a success. So the next step is to try it out on mobile. iOS and Android is something that we want to test next. So we've always planned this, but obviously we got to make some changes. The UI and UX needs to be made more mobile and touch-friendly. There's some mock-ups that Sim has already created in like 2 hours or something. He was really fast at it. But we also need to make some optimizations, most likely. We specifically in the navigation agents are demanding a lot when there's a lot of enemies on the screen. We haven't really tested it on a mobile device yet, but we assume that might be the bottleneck. For porting to mobile, there's lots of plugins to help from the open source community, but part of the difficulty will be sifting through all the options and picking one that's actually right for us. Maybe none of them are, in which case we may need to get someone to write something for us, which of course would incur a cost, so there's a risk there. And of course, what everybody wants to hear, if you like the game, there's going to be more content. We're excited about what we've made so far. We now have a nice base, and now we just want to add more levels, more towers, more fun. So if you guys have tried it or you want to try it, keep an eye out because there's going to be more coming. So.
Yeah. And if you guys have any questions about releasing our game in Godot, please ask them now. Thank you.
Questions?
That sir over there was very quick raising his hand.
Oh, okay, sorry. Hi, I'm Fabrizio. You talked a lot about a lot of tools and the fact that you're now going to probably go to mobile, and for that you have a suspect that your nav agents are the culprit. Is there any? I'm really not familiar with Godot, but is there any profiling tool that is like community provided or official that is available?
Yeah, so there's profilers in the Godot engine. However, if you want to release to mobile, you'll probably have to use a profiler that works on that platform. And depending on your platform, if you go to iOS, there's built-in profiling tools in Xcode. If you go to Android, there's a lot of profiling options in that sense. But it's not the same as in Unity, where you can do a lot of the profiling on device. you will have to use external tools, but those exist, and those are probably also better than what you would find in something like Unity, because they're very device specific. Yeah, so those exist, yeah, profiling, yeah.
Any more questions?
Crickets. Yes, okay, see there.
He has a built-in microphone.
You mentioned that you taught yourself the engine. How long did it take you, and how much experience in programming did you have beforehand?
Yeah. I also have an indoor. No, but so like I said, I came from a wind power industry where I pushed a lot of PowerPoints and stayed in meetings. So I had very, very little programming experience before I jumped into it. I started in about September 2023, and then I started working with Adriaan in about September 2024. So about a year to build experience of doing tutorials and looking at the documentation. So from about January onwards of that year, I started building my own project and going through all those typical hurdles of like doing everything wrong, but it was a great learning experience, having a prototype that he and my close loved ones have only seen the light of day because it's embarrassing to show, but it showed enough, and I learned enough to make me a hireable prospect. And since then, I've been learning a lot on the job as well. But yeah, so about a year.
And maybe also from someone who has had 10 years of experience in Unity, a lot of the high-level concepts, they basically transfer. So it took me about maybe a month to get to understand Godot intimately enough so that I could make games in Godot, yeah.
You're here for the rest of the day?
I will not.
Oh.
I'll be here for the next hour.
Okay. You're going to stick around?
Well,
If people have questions.
they should come to us in the next hour.
At the coffee break.
Okay, we have to wrap up. Thank you very, very much.
Thank you.